Hey everyone, and welcome back. In this lecture, we'll continue our discussion on our project stock market analysis. We'll start by visualizing the daily return for the stocks. So for this, the first thing we'll do is add a new column. We can call it, let's say, daily return, and then calculate the daily return by calculating the percentage change from the adjusted close amount. Let me give you an example. For instance, if I take our stock Walmart, and then we can add a new column, let's say daily return, and then we can set it to be equal to, we have our Walmart adjusted close amount, then we'll call the percentage change method on it. That percentage underscore change. Okay. Now, if we call our Walmart data frame, we'll see that a daily return column is added, and it's calculated from the adjusted close amount. Okay. So here, for instance, for October 14, 2015, the daily return is negative. It means the daily return for that day is negative, whereas wherever it's positive, we see that there is a daily return. Okay? Let's see this by visualizing it. So we have our Walmart stock, and we'll be considering the daily return column. So let's index that, and we'll plot it. Okay, and let's pass a fixed size of 10 by 6. Let's pass the line style attribute. We'll use a colon. Marker, let's use O. For color, let's use blue, and I'll set the legend to be equal to true. Let's run it and see what it looks like. Let me make the graph, the figure, a bit bigger. I think we can still make it larger, 10 by 10. Let me make this 13 by 8. Yeah, it looks much better. So here we have our daily return. So this data represents a single day. And daily returns above 0 means there is a positive return. Below 0 means there is a negative return for that specific day. So one dot represents one day. We started on October 12th, I believe. So October 12th, October 13th, 14th, and so on for each of our days until today's date, February 3rd. Okay, that's what they indicate. And for positive daily returns, the dots will be above 0, and for negative daily returns, the dots will be below 0. So one information that we can get from this is that we can easily see how many dots we have above 0, or we can compare, the daily return for this stock between the dates October 2015 to February 2017, and see whether we have most of the daily returns above 0 or below 0. So that's one information that we can get from daily returns. Okay, this is for Walmart. Let's do the same thing for a couple more other stocks. Let's consider Google. So we have our Google stock, and the first thing we'll do is add a daily return column. So daily return, and we'll calculate that from the adjusted close amount. We'll call the percentage change method. So we have Google adjusted close that percentage change. Okay. Now if you look at your Google data frame, that head, you'll see that a daily return column is added, and positive values correspond to a positive daily return, whereas negative values mean a negative daily return for the specified date. Okay, now we can visualize it by plotting it. Let me copy, paste it here, and change the symbol to Google. Okay, line style, marker, color. We can use a different color, let's say green, and run it. Again, daily returns above 0 means a positive daily return, and values below 0 means a negative daily return. And each markers represent values for the specific day. And again, we see more of these markers above 0 for this time period, right? So that's one general information that you can get by considering this daily return. Let's consider one more stack, Starbucks, and let's calculate the daily return for it. We'll first add a column called daily underscore return, or you can name it whatever you want, and that will be equal to our Starbucks. We'll take the adjusted close amount and calculate the percentage change, percentage underscore change. Okay, now if you take your Starbucks, then let's see the first 10 rows. Okay, this is what it looks like. So we have 5 of them above 0, 4 or 5 of them below 0. And to visualize it, let's change this to our sticker symbol, Starbucks, and color. You can use any color that you want. Let's try red. Run it. Here we have our daily return for our Starbucks for the time period October 2015 to February 2017. Markers above 0 indicate a positive daily return, whereas markers below 0 indicate a negative daily return. So we have various ways of visualizing our stacks to get general information, right? In the previous lecture, we drew a graph to see our adjusted close amount. We can grab the information that we want just by looking at this graph. And in this lecture, we are considering the daily return amount, right? And one general information that we can obtain is compare the daily return, whether it's positive or negative, just by checking if those markers are above or below 0, and see the proportion. Okay, sometimes it could be hard. For instance, in here, I cannot exactly tell whether I have, more of the markers above 0 compared to below 0. Okay, but you can try out this method and see what you get for various other stacks. Great. What we'll do next is create a data frame of our stacks. We'll consider the stacks and the adjusted close amount, and we'll create a data frame from those. Okay, and we'll save it in a variable called stacks. So I'll set that to be equal to pd.dataframe, and then we'll pass symbols for our stacks. Let's say Apple, AAPL, and then the adjusted close amount, adjusted close. And let's do the same for all our other stacks. We have Starbucks. We'll take Starbucks' adjusted close amount. So Starbucks, adjusted close. I am putting each stack on a new line for better visibility. We have Walmart. So the order doesn't matter. You can put it in any order that you like. Next we have Google. So Google adjusted close. And finally we have ExxonMobil, XOM adjusted close. Okay, now we have a data frame consisting of the adjusted close amount for each of the stacks. So we can visualize our data frame by calling the head method. So we have date and then Apple, Google, Starbucks, Walmart, and ExxonMobil. So this is the adjusted close amount for each of our stacks. Okay, and if you call stacks.tail, you'll see the adjusted close amount for the last 5 days. Okay, what we'll do next is try to visualize the adjusted close amount by calling the plot method. And here you see a plot. So if you remember, we had a similar plot in our previous lecture. So if I go up here, so it's similar to what we have here. So we can pass the fixed size attribute and set it to be, let's say, 10 by 6. Run it again. And in the previous lecture, we discussed that we can only see the Google price, right, compared to the other stacks. So the other stacks don't look more volatile, right? They kind of look stable, and we cannot get much information from them. That's because the price for Google is expensive, and and that has some effect on our other stacks. And we mentioned that we'll have a solution for that. And one solution is to plot the stacks return instead of just the adjusted close amount. Okay, one thing we can do is consider the stacks return between the time periods for our stack analysis. So we'll calculate the stack return between October 2015 to February 2017. Okay, so we'll take our stacks data frame and then transform it so that we can get the stack return instead of the adjusted close amount. So that way we'll be plotting the stack returns for each of the stacks instead of the adjusted close amount. And there are various methods to calculate the stack return, but we'll take a simple method and then just take the price, the price here, and then divided by the initial price, and that will simply calculate the stack return. Let's do that. So we have our stacks. So this is our data frame, the stacks data frame, right? And one method is by using the apply method, we can transform our stacks. So stacks.apply, and let's use some lambda function. Let's say lambda a divided by a at index 0. Okay, so simply take the price x, so lambda a, then a divided by a0. Okay, so price of the stack at time period a divided by the initial time period. So that will calculate the stack return for our stacks. And we can save this in a variable. Let me call it stack return. And now let's call the head method on our stack return object, that head. So this is what the stack return looks like for each of our stacks: Apple, Google, Starbucks, Walmart, and ExxonMobil. And we have each of the dates, right? We have 1, 1, 0.98, 1.02, and so on. And if we consider the last 5 rows or 5 days, we can call the tail method, run it, and that's what it looks like. You see, now we can plot the stack return values. So the values, they have close, right? The values are really close. So we won't get a graph like this. We'll get a graph that will be close to each other. So let's visualize it now. We have our stack return, and let's call the plot method on it. Run it. Right, it looks much better. Let's pass the fixed size attribute. Fixed size, say 10 by 8. There you go. So now we have our 5 stacks. Apple is in blue, Google is in green, and so on. And this is the stack return for each of our stacks, right? Now we can see that all the stacks are volatile, right? And we can get more information from this graph versus the one we saw earlier, right? You see here, you can't tell much about any of these 4 stacks. It looks kind of stable. And that's not good information or enough information for us. But here you can get more information about any of the stacks, right? This is the stack return. For instance, if you take Google, right, it starts from here and then it looks volatile, right? None of the stacks are stable, but you can tell, by considering this time period, you can check if there is any stack return or not. That's your overall check, or you can consider a specific time period. For instance, the one in blue is what? Walmart. So if I take Walmart between the time periods June 2016 and February 2017, there looks to be a positive stack return, right? Whereas if I consider the time periods between about February 2016 and August 2016, there seems to be an up and down for the stack return, and looks like not much difference. So those are some information that we can get about the stack return.